Okay, welcome back to our discussion on the fundamentals of the Go programming language. So in this lesson, I want us to look at error handling. I know that prior to or up to this point, you have not done any error handling in your C++ programming courses. Okay, so one thing that you need to recognize with Go, handling errors is a sort of a centerpiece of the language. It makes error handling a focus whereby your program has to handle errors um, and it makes it sort of easy to do so. All right, so to demonstrate this, I will navigate to my uh, directory here and create a new one. And notice I'm just using the GUI interface to create my directory. Scarless errors. Okay. All right, so let me open a terminal. So I'm going to click on this. Actually, let me open it. So I am inside errors. I'm going to right click, open terminal. Okay. It's currently empty. So I'm going to quickly make a main.go file along with a go.mod file. So I'm just going to say touch main.go. And then I'm just going to do everything. So I'm going to use the ampersand sign twice. And then I'm going to say go mod init Lewis Alwyn /app.net /errors. And then I also want to run go mod tidy. And then if that works, I want to open this directory in Visual Studio Code. Okay, so in Linux, you can type a list of commands and you separate them with the ampersand twice. So what this is telling me is run this command. Okay, so if it successfully makes this file for me, then I want it to run this command. Okay, run this command. And if this command works properly, then I want it to run this command, go mod tidy. And if that command runs properly, then I want it to run this command. Okay, so this is the equivalent of me typing touch me.go, enter, go mod init lewisdarwin.net /errors, enter, go mod tidy, enter, code dot enter. All right, so I don't have to do all those enters. I just do it on one line and I separate the individual commands with 2 ampersands. Okay, and so I'm going to wait for Visual Studio Code to open. All right, and it opens. Okay, so just a little tip when working with Linux. Okay, remember the point of this class is also to learn about a bit about Linux. Okay, so my screen looks kind of tiny. Let me see if I can make this a bit larger. Let's see, Control. Okay, yeah, Control Shift plus. Okay, so let me create my package main. Okay, and so I want to demonstrate error handling. Okay, so say fmt. Okay, so let's say I want to create a function that is named area, and this function should accept a length and a width, and it should return the area. Okay, and so I could do that. I could say func area. Let's use small a for area. It takes a length, it takes a width, and these have the type float 64. So notice I don't have to say length float 64, width float 64. If the parameters I have, if all of them are the same type, I can just list them, and for the last one, I put the type. And the Go compiler will know that both of them have this type. So if I look at width, it tells me float 64. If I look on length, it tells me float 64. Okay, that's another tip for Go. And it should return a float 64. Okay. And so let's just return length times width. Okay. All right, it's easy enough. So let me test this by calling this function inside my main. Okay. So I'm going to simply say, what is it? I'm going to say result will be area. I'm going to pass in 11.5 along with 2.5. Okay. All right, so let me just print the result. Otherwise, it will continue to show the result in red. And I'm just going to say result. Okay, so a straightforward program. Excuse me. Let's run it. Okay, so let's say go run main.go. All right, and I get an answer. So let's look at errors. What would happen if I put in cookies in here? Okay, and I try to run it. Oh, sorry, I didn't save it. So let me save it. Okay, I've saved it. All right, so the compiler tells me, cookies, that's a string, but the function requires a float in the first position for length. So this code will not compile. Okay, and the compiler ensures that whatever function you're calling, the type matches up. So cookies obviously is a string, but length expects a float. So, the compiler is helping us there. So, no problem. Now, what happens if I instead put -15? Okay. Let's see if the compiler catches this, because as far as I know, the area, a length can only be a positive number, right? And a width can only be a positive number. Oops, I didn't save it. Let me save it. Okay. Always remember to save before you compile. Okay. All right, so it gives me back -37.5, which doesn't make any sense because I can't have a negative area. Would the compiler do the same thing if I have a negative width? Let's save this and let's try again. All right, so let me verify and tell you that it's two different things. I'm going to change it and you'll see you get -30. So the compiler is not helping us in making sure that the values entered are positive. So we have to deal with this ourselves, right? So how do we do that? Well, it's kind of straightforward. This is what we're going to do. If any of the values that are entered, that are passed in, are negative, or meaning less than 0, then we will send an error message to the user telling them that, you know what, you tried to use a negative value, but it's not allowed. All right. So how do I specify that my function can return an error? Well, I need to know what is the type of error messages, okay? Because remember, float 64 means that the answer I sent back is a float 64. So if I'm going to send back an error, what type are errors? Well, it turns out that the type for errors is the error type. Okay, so in Go, there's a type called errors. Okay, now I need to put a parenthesis around this. Okay, so whenever you have more than one return values, you put them in parentheses, separated by comma. So what this function is now telling me is this function will return two values, a float 64 and an error. Okay, great. And so inside our function, we will check to see if length and width are negative. So if length less than 0, then I want to do something. I am going to return, let's say -1, and I'm going to return some error message, right? Okay, that's what we want to do. Okay, so I have the -1, that's easy enough. So how do I return an error message? Well, I have to create an error message. And so I'm going to say error, which is the name of my variable, which I'm going to save this error message into. And I'm going to say errors, okay? And so this package errors allows me to deal with errors. So let me include that. So I'm going to put that right here, errors. Okay. Now, one thing you notice, whenever you're listing these packages in the imports, you make sure you put them in alphabetical order. So since error begins with E and format begins with F, well then the error package name comes first. Okay, that's just the convention. It makes it nice and neat. So I'm going to say errors, and how do I create an error message? Well, there's a function called new. And all I have to provide to this function is the error message. Length must be, and by the way, when we deal with errors, we use small letters, okay? To begin, small letters. So I prefer a small L for length. So length must be greater than or equal to 0, okay? So this is, right? So if the length is less than 0, well then this is what I'm going to return. And remember, this works. Line 11 works because I will return -1, which is a float 64. Okay, if you want to be explicit, you can say 1.0. And I have to return an error. So let's return error. That's the error. Now, what happens if the width is less than 0? Well, we could do the same thing, right? So we'll do another if. We don't do else. We can't do an else, right? Because it won't work when both of them are negative. All right, so that's why we have to have two separate ifs because we want both of them to be checked. So if width, and I think all of you know that, but I'm just repeating it, less than 0, then I want to say that there's an error, okay, and we're going to create a new error, and it's going to say width must be greater than or equal to 0. Put a full stop. Okay, and then we will return negative 1.0 followed by the error message. So some of you might be asking, why do we return if there's an error? Well, we return. Remember, return means to leave the function. So there's no point in remaining in the function if one of these are negative. What's the point? You can't calculate the length, you can't do length times width because one of them is negative or both of them are negative. So why continue? So that's what we do. That's what we mean by returning. So you have an error, just leave the function. All right. So you have to leave the function, but make sure you send back two things that are expected. Okay. So if the length is positive, this will be skipped. If the width is negative, this will be executed. So what happens if the length and the width are both positive? This will be skipped, this will be skipped, and then we'll get to line 18. So it's telling me something is wrong, right? It says wrong number of return values. I want 2, but got 1. So remember, this is just one answer. I'm supposed to return 2. There are no errors. So what should I return for the error? In Go, when there is no error, we use the nil value. The nil value. Okay, so the nil value, you'll see it over and over and over again. Just know that the nil value means that there's an absence of error. There's no error. And so to say that the function works properly, you return the value, the area, and then you say nil. Okay. And so now this is my complete function. Let's run it. Let's save it actually. Let's run it. But now it's telling me on line 22, see, mismatch. One variable, but area returns 2. I am only saving one answer. I call the function and I have one variable, but this function returns 2 things. So that's what Go is telling me. So all I need to do here, I'm going to put a comma and put another variable. Let's call it, we usually call it er. Okay, that's the convention. Call it er. Okay, so when this function is called, the float 64 will be saved in the first variable result. And the second thing, which is the error, will be saved in the second variable. Okay. Now this is the part that we must handle the error. Okay. So this is a pattern. So make sure you follow this pattern. And you see this pattern in Go code that you will read. So I will say, if error not equal to nil, something went wrong, right? So if error not equal to nil, then I know something went wrong. And so I can simply say log that fatal, and then I'm going to say error. Okay. So all this is saying is log that fatal means stop the program, halt the program, stop it. Okay. Okay. All right. And then, of course, the error message will be printed out. Now, if the error is not nil, we will stop the program. Now, if I provide 2 positive values, then the error message will be nil. So this if will be skipped, right? And so if this if is skipped, we'll end up at line 27. And so what do I do on line 27? I print my answer because I know the only way I can get to line 27 is if this if was skipped. And the only way this if is skipped is if the error is nil, which, as you recall, means the program got the expected parameters and the program worked as expected. Okay, so let's see this in action, right? So notice it's telling me, right? So it halts the program. Exit 1 means stop the program. So it stops the program and it tells me what was the problem by printing the error message. Likewise, if I put this one here, okay, save it, and I run it again, it will stop the program, telling me the length was greater than or equal to 0. Right? If I make both of them negative, save it, it will still give me errors. Right? However, if I make them valid inputs, then you'll notice that the program will work as expected. 15.5. Okay, 2.5. Okay, let's check again. Okay. All right. So one thing I want to mention though, this log, this fatal function comes from the log package. So notice Go Visual Studio Code automatically included it for me. Okay, that's because I set it up that way so that if I use a package that's not here, it puts it for me. Okay, but normally we want to put it ourselves. Notice E, F, and then L, alphabetical order. All right, so I have an error. What does it say here? Oh, okay. See, it's telling me that error messages should not end with punctuation marks. Okay, remember I told you that they should not begin with capital letters. They should also not end with punctuation marks, right? So it's telling me error string should not be capitalized. So that's the warning. So let's please the compiler by doing what it's telling us. Okay, so now the compiler is stop complaining. And so our program works flawlessly. Okay, so this is what I mean when we say we are handling errors. This is simple. Okay, so again, you have the function. If the function if the inputs can cause the function to produce wrong outputs, and we want to tell the user or we want to notify the user about that, then we say we handle the error. Okay, we handle errors. And so to handle errors, you have to specify that your function returns back an error. Okay, and so once your function returns back an error, then whoever uses your function, okay, so if I click here, you'll see that I am told that this function takes two values and it returns two values. One of them is a float, and one of them is an error. All right, and so you have to always be checking for errors when you are using Go packages. All right, so let me actually give you an example of that. So let me finish here. After we handle errors, if there are any errors, we simply return. If there are no errors, we simply do what we need to do, but we return nil. In the main function, when you call the function that you're using, you have to explicitly create a variable to store the error that is returned. So one variable stores the value, the float value that is returned, and one variable stores the error value that is returned. And then you have to actually check the error value to see if it's nil or not. If it's not nil, then it means that there was a problem. And then we need to either halt the program, meaning stop the program, kill the program, or we could do something like fmt that print the error message. Okay, now when I print the error message, this does not stop the program. It doesn't halt the program. Okay, and so if you notice here, when I run this program, go run main, it tells me that there was an error, right? But then it still goes ahead and executes line 27, right? Right? Which is -1. Okay, because the -1 would have been stored in result. All right, so always be mindful of what you want. Do you want to print the return value to show the user and say, okay, user, see, -1 is returned? Or do you want to just halt the program? Okay, so that's where you have to decide for each situation what you want to do as the programmer. Now, I've been talking about errors, and so errors are a part of Go, whereby you pretty much have to use them and get used to them. So what do I mean? Let's say, for example, I look at Go open, well, OS. Okay, OS. Okay, let's say I want to open a file, and so I have to use the OS package. Okay, and all I need to do, I say, okay, I need to use the OS package. So where is a function that would allow me to open a file? And I keep looking and I say, is there such a file? And I see, oh yes, here is one. And I read it, all right? And I say, okay, how do I use this thing? Well, it's open. It takes a string. It takes a string and it returns a pointer to the file, meaning if it opened the file, it gives me a pointer to the file. It tells me that's where I saved the file for you. Go, okay? And then it also returns an error. So when I am writing code that uses open, automatically I know I have to check for the error to see if it's nil. Okay? And so if I want to see an example, if I say, I wonder if there's an example of this. So let me come here, right? So if I come here and I check, is there an example? Well, let's see. Nope. Okay, here's an example, but this one, open file. Okay, open file. So open file takes string int and a file mode. Okay, but it returns also an error and of course a pointer to the file. So don't worry about what this really means. All I want you to understand is when you're using some function and some package in Go, your job is to look at the documentation and see if there's any error you need to check for. Okay, and so this one tells me there is an error. And if I look at the example code, I'm pretty sure there has to be a check for it. And see, right here. Right here. So I open the file, I pass in the parameters, and then I save the answer in F, and then I save the error in R. And of course, I have to check error. Okay, and if everything works out, then I have to close the file. And again, what do you notice? I am checking for error. So I'm pretty sure if I go and I look at this close function, where is this close function? I'm pretty sure I will see that it also has a, it also returns an error. See? So the Go documentation is very predictable. Writing Go programs is kind of straightforward because documentation is very good and it tells you when an error is returned from a function or not. And if the error is returned, you have to check for it. If it's not returned, then you don't have to check for it. It's straightforward. Okay. So I have used error handling in Java. I have used error handling in C++. I have used error handling in Python. And I have now used error handling in Go. And if I were to compare all of them, I prefer to use the error handling approach in Go because it's straightforward. Okay, it's streamlined, straightforward, and it's supported in such a way that it helps you to check for errors. It makes it easy to check for errors, and so that way you write better code. All right, so that is my discussion on error handling. And of course, this is just an introductory video on error handling. As the need arises for us to do different kinds of error handling, where we have to use different approaches, then I will discuss that before you actually do or before you actually need it. Right? So I don't want to overload you with all the possibilities of handling errors in Go. I only want to show you the basics. When we need other things, you will know it then. All right, so I'll leave it here. All right, and please keep in mind that I am showing you error handling on functions, but since you already know how to use methods, right? Methods from the last lesson, you could also apply error handling to those methods. All right, I'll see you in the next lesson.